Hey everybody, I'm going to be recording a lesson here. Actually, you're seeing the recording now for our third lab. This is going to be our graphing lab. I know that the last graphing lab that we did, it gave some people a bit of a challenge, so I decided to make a video for this lab. Not every lab will have a video. Some of them you got to just kind of try to figure them out, follow directions, but because this graphing lab does have some details that you might benefit from a video, I decided to video it for you. So again, this is going to be lab number 3. It's all about graphing and the rate of change. It's different than lab number 2, which is graphing and density, so don't get the two of them mixed up. So we will start. We're going to do the introduction. Of course, make sure you fill out the heading up in here. The date of this lab, the vast majority of you guys are going to start this at the end of the week, which I believe is 10/2, so October 2nd. Again, it's going to be lab number 3. So just make sure you fill that in, of course, your name and instructor, the period that you have me. Okay, so we are going to start off with the introduction. So I will read this to you. I may tell you to underline some things, and I will hopefully highlight or underline them. You know what, let's go for the highlighter on this one. And definitely do that on yours because it will be helpful for you to understand some stuff later. Underline it now because, it'll help you understand it, but it'll also help you for some questions later in the lab. So here we go. Introduction. Constructing and interpreting graphs are integral parts of any earth science course. This lab presents a review of graphing with an emphasis on the rate of change. A graph is a diagram that shows how sets of numbers relate to one another. The sets of numbers that are being related are called variables. Graphs arrange information into a picture form. The information that you want to graph is called data. Now, one of the things that you should understand is that graphs make it easier to see patterns, okay, and trends in data. You want to kind of underline that or highlight it in your own version, okay? And a graph is a visual way to organize and present data. A graph helps you to visualize changes in data, to understand relationships between variables, okay, I'm going to keep underlining, within the data, and to picture trends or patterns in data. So graphs are really important because what they're trying to explain to you, what we just highlighted, is the understanding that graphs actually give you a visual presentation of data. Sometimes when you look at numbers, it really doesn't make much sense, but when you put it into a visual form, a graph, it makes a lot more sense. So it says this exercise is to plot using a line graph the data presented for each graph. As you recall, independent variables are usually listed along the x-axis, whereas dependent variables are typically listed on the y-axis. So let's go straight to your objective and vocabulary. The objective of this lab is to illustrate data in a way to easily determine relationships of variables. And we're going to start with the vocabulary rate of change. For this vocabulary term, the easiest thing to do is to go to your earth science reference tables and simply copy down the rate of change formula. And that would be the change in value. So we're going to write down the change in value. And that's going to be divided by, right? We could do a divided line. Mine's kind of, sorry, a little bit wavy here. Divided by your time. Now, if this is brand new to you, okay, if you do not know what this formula is or how to manipulate this formula mathematically, stop this video now, and you need to go back to my previous video from Tuesday or Wednesday of this week. I'm sorry, I shouldn't say Tuesday, Wednesday or Thursday of this week, right? Go back to my previous video on rate of change, explaining how to actually functionally do this mathematical formula. Because again, if you don't know how to do that, this whole lab is going to be super confusing to you, okay? So stop this video now if you don't understand that formula yet or you haven't had experience with it yet, okay? Now, for direct relationship, off to the side, okay, what a direct relationship graph looks like is basically on the line, on the graph, you have a line that kind of increases. It goes up as you go across the graph. So you may draw a little picture of a graph, okay, show the direct relationship. In the actual lines for direct relationship, what you probably should write down is that as one variable increases, so does the other variable. I'll repeat that one more time. So as one variable increases, so does the other variable. So both variables are increasing, both the x and y axis. Okay, so your inverse relationship, guys, your inverse relationship off to the side of the actual definition, you can draw a little picture of a graph, and you're going to show a line decreasing on the graph. And your definition for this one would be, as one variable increases, the other variable decreases. Again, indirect or inverse relationships show usually something increasing on the x-axis, and what's being plotted on the y-axis is decreasing. So like, for example, if I took time and I put time in minutes on my x-axis, and then I plotted the temperature of a cup of coffee that was sitting out on the counter, you would see that the cup of coffee's temperature would decrease over time. Okay, so that again, the time is going up, but the temperature of the coffee is actually going down. So again, that would be an inverse relationship. Okay, make sure you write something down on the blank with what I just described. And then for independent versus dependent variable, for the use of this lab today, for independent variable, we're just going to put, x-axis. Today we're going to be listing our independent variables on our x-axis, which are typically like your time. Okay, whereas your dependent variables today, we're going to be listing on our y-axis, and those can be of various different things. Today, we're going to be looking at a bunch of different dependent variables. Okay, so just make sure that you obviously have definitions for these three. Again, I verbally just gave them to you. You might have to pause and go back and, rewrite them or write them down, and then pause the video while you're getting that actual definition down before we get to the next one. So just make sure you have definitions for all vocabulary. And again, if you don't like my definition, you're free to go look them up on dictionary.com. That works too. So let's get to procedure A. Peter and Steve. There's these two guys, Peter and Steve, and they decide to embark, which means go on a bicycle race. And the race is about 10 kilometers in length. And it says down below, you are to plot a graph with the two different colored pencils. Don't forget to make a key. And you're going to be plotting the information from the data table. These times are listed in minutes and seconds. So again, we can see that Peter and Steve very clearly had a race. Okay, their bicycle race went on for 10 kilometers. Peter, did his full race in 12 minutes and 50 seconds. Where Steve, you can see, was a bit slower. It took him almost 2 times the amount of the actual time to get to his end result, which was 23 minutes and 20 seconds. So what they want you to do is first plot Peter and then plot Steve. Okay, they ask you in the directions to kind of make a key. It's very simple to do this. I'm going to choose blue for Peter, and I'm going to plot Peter's times first, and then I'm going to go and do Steve in a different color. So if you look, 1 kilometer, Peter did 1 kilometer in 2 minutes and 20 seconds. So if you kind of look here, your distance is listed here in kilometers, whereas your time is actually listed on the y-axis. Okay, this is a little bit reversed from what I had put in the vocabulary, but that's okay. Typically, time does go along the x-axis, but time is listed in your y-axis. One of the things that you should notice is that these lines are, some of them, not labeled. Okay, if we look at the y-axis here, the lines are going up by 20 seconds. So this would be 0. This would be 20 seconds, 40 seconds, 1 minute, 1 minute and 20, 1 minute and 40, 2 minutes, and so on. Now, across your your x-axis, you have distance. This is going to be 1 kilometer, 2 kilometers, 3 kilometers, and so on. So we're going to start with Peter. Peter at 1 kilometer had rode 1 kilometer in a time of 2 minutes and 20 seconds. So I'm going to go to 1 kilometer. I'm going to go up to 2 minutes and 20 seconds would be that unlabeled line right there. So from 0, I'm going to connect into my first dot. Hopefully your line's a little bit straighter than mine. You can use a straight edge at home. I like to personally kind of cross the data off as I do it, or at least kind of make a check. Okay, did that one, go on to the next. So Peter, at his 2 kilometer mark on the race, he was at 4 minutes into his race. So I'm going to go to 2 for my distance, and I'm going to go up to 4. So again, here's your 2 for your distance, and I'm going to go up to 4 minutes. I'm going to make my dot. Again, I'm going to connect as I go. All right, that data is done, and you are going to continue on. I'll do one more dot to give you an example of Peter, and then you can pause this video and you can finish Peter, and then we're going to go on to Steve. So Peter, at 5 minutes and 40 seconds, he had gotten to his 3rd kilometer. So 3 kilometers is here. I'm going to go up to, let's see, that's his 5 right here, 520, 540. You put a dot. Again, you're going to connect the dots as you go. So I did the first 3 sets of data. You're going to continue until you get to 10 kilometers. Then, okay, what you're going to do is we're going to do Steve. So again, if you want to pause your video now, finish plotting your data, then we are going to continue on. So continuing on, we got Steve. And I'm going to choose a different color for Steve. It said to kind of make a key, and this is very easy. All I have to do is color a little color swatch of any color you want. I'm going to choose green. Blue and green are my favorite colors. So I'm going to start plotting Steve. So Steve starts, okay, his race, and he doesn't get to his first kilometer until 4 minutes. So right here, we're going to go to 1 kilometer. I'm going to go straight up to 4 minutes, and I'm going to make my first dot. I can come in from 0 and connect to that first dot. Okay, again, I like to check my data off as I've done it to keep track. At 2 kilometers, Steve was at 7 minutes and 20 seconds. So I'm going to go to 2 kilometers. I'm going to come up to 7 minutes and 20 seconds, which would be about here. I'm going to connect in, and I'll do one more piece of data with you, and then you can pause this video to continue Steve. So Steve, his 3rd kilometer was done in 10 minutes. So 3 kilometers, I'm going to go all the way up to 10 minutes. And 10 minutes is there. Again, connect your data as you go. So here you got 3 plotted points. Well, you should actually have all of Peter's done. You have 3 plotted points for Steve. You can pause your video at this point to continue Steve. You're going to see a very general trend. Okay, Steve will kind of go up, the same kind of pattern. Peter should have done the same. It kind of goes up at its same kind of pattern. And you'll have 2 lines that kind of go across your graph just like so. Okay, once you're done plotting both, okay, I drew mine in here, but you obviously should have plotted points. We are going to go on to our questions. So question number 1, it says Peter's finish time was how many minutes and seconds? This you get right off the data table. Peter had a finish time of 12 minutes and 50 seconds. And then the next question says what was Steve's finish time? And Steve's finish time, again, right up to the data, 23 minutes and 20 seconds. Fantastic. Questions 1 and 2 are done. Let's go to 3. Now 3 and 4 are rate of change questions. Remember, the rate of change is the change in value divided by the time. So they're asking you to calculate the rate of travel in kilometers per minute, okay, for, first one is Steve. So what I'm going to do is I always remember that time goes down on the bottom. And they said do it for the first calculate the rate of travel in kilometers per minute for Peter. So I'm thinking about the total time it took Peter to do this race. And if I look back at my data, it took Peter 12 minutes and 50 seconds to do this entire race. So again, what I'm going to do is I'm going to put down here 12 minutes, right, and 50 seconds. And that's my time. And the total, okay, distance that he rode was a total of 10 kilometers. So we did 10 kilometers at the end. He started at 0 kilometers. So this is my change in value. And again, I'm doing my change in value divided by my time, my total time. So if I break this down, 10 minus 0 kilometers equals a total of 10 kilometers. And simply what I'm going to do is I'm going to divide that by a total time of 12 minutes and 50 seconds, which is how long it took him to ride the race. And again, when you do 10 divided by 12 minutes and 50 seconds, you're going to get, okay, a decimal. In this particular example, I get 0 point, I think it ended up, actually, let me grab a calculator so I can give you the exact number and show you how I round it. But again, if I do this in my calculator and I do 10 divided by 12.50, it actually goes exactly, it doesn't give you a long number, which is great, 0.8. Oops, sorry about that. Let me just erase that and make that a little clearer to you. Hang on. Make it nicer writing. Slow it down here a bit. That should be a total of 0.8, and it's going to be kilometers. And this should be per minute. Okay? And again, you're just taking the total distance and dividing it by the time. Now, you're going to do the same exact thing now for Steve, right? And if I look up for Steve, Steve took 23 minutes and 20 seconds to ride 10 kilometers. So again, the time always goes on the bottom. It's going to be 23 minutes and 20 seconds, right? And he did a total of 10 kilometers. Okay, 10 minus 0 equals 10. So again, you set your problem up, you're going to divide, and it's going to tell you how many kilometers per minute Steve rode. Again, this is going to be a decimal. So you're going to get your answer by doing 10 divided by 23.20. And again, that will break down to a decimal. We can round it to the nearest tenth, and it would be kilometers per minute. Okay? Now, once you're done with that, it says who bicycled faster, Peter or Steve? How do you know? Okay, obviously Peter went a lot faster. He finished the entire 10 kilometers in only 12 minutes and 50 seconds. Okay, how do you know this? You looked at the data. You could also say, you looked at the graph. Either way, it's fine, but definitely support your data. It says, how do you know? So you have to say how you know. Question number 6, it says, which better illustrates the change in rate, the data table or the graph? There's really not a wrong answer to this. Personally, I like how graphs illustrate data better because it creates almost like a picture view of what's happening over time. Okay, so again, if you say you like the data better, I wouldn't mark you wrong, but most people do choose the graph. And then it says explain why you chose what you chose in 6. And again, I choose to like graphs better. Like I think data looks nicer in graphs because it kind of presents a very visual way of you seeing that data, okay, that they're trying to organize. So again, you put down what you think for 7. I put down what I think, right? No answer would be wrong there. Just make sure you support your answer. So that brings us to procedure B. And it says base your answers to the following questions in graph A. It represents the flight of 2 weather balloons that were released from different locations. Just so that you guys know, a weather balloon is a thing that scientists, meteorologists release up into the air. These weather balloons rise up from the surface. They're filled with helium. They're meant to rise all the way up, and as they're rising all the way up, they have an electronic box. It's called a radiosonde. You don't need to know that. But what the radiosonde does is they switch it on and it records information about the atmosphere. As it rises through the atmosphere, it tells us things like how fast the wind's going and what temperature the air is, the humidity, stuff like that. So here are 2 weather balloons. Weather balloon A got released, it seems like it was on top of a hill. It started off at a height of 400 meters. And it kind of increased at a very steady rate, right? It kind of went up very steadily. Whereas weather balloon B was released probably down by an ocean. And the way I know this is it was released at 0 meters. 0 feet or 0 meters means down by the ocean, by the sea. And you can see that B kind of goes up at a very steady rate until it reaches the 4th minute. At minute 4, instead of this actual balloon continuing on its same trend, which would have meant it would have gone up kind of more of a straight line, you can see that the line begins to slump over here. And again, that shows some type of change in its rate that it was going up. So we are going to attack these questions 1 through 6, which are all based on this little graph here. Question number 1, are balloons A and B increasing or decreasing in altitude? So guys, you can clearly see that both of these are increasing in their rate. They're going up. Again, B slows down at its rate of increase, but they're both going up. So question number 1, it most clearly is increasing. So 1, they are increasing. You can write it on the line, increasing. Okay, now question number 2. What was the rate of change for line A? From 0 minutes to the 4th minute, show your work. Okay, remember what rate of change is. It's the change in value divided by time. So if I wrote that down, right, the time always goes underneath. So I'm going to use this little triangle that means change in science. It says change in value divided by the time. So I have to think about this. The time that they gave me was from the 0 minute to the 4th minute. So my time goes down here. Okay, I'm going to be dividing by 4 minutes. Now what was changing? The height of balloon represented by line A. So I'm going up to the one that says A. And I'm going to start at the 0 minute. 0 minute is here. And I'm going to go up to the line. And it started at 400. So 400 meters, okay, is going to be one of my values. My second value is going to be done for the 4th minute. And I got to go up to line A again. And I find out that it was at 800. So here are my 2 values. I've got a difference of 800 meters minus 400 meters. And if you think about this, the difference between 800 and 400, it equals a total of 400 meters, and you're going to divide by 4 minutes. Again, you want to do this in your calculator. And when you do the 400 divided by 4, it gives you 100 meters per minute. By the way, I think they mistyped this. This should say meters, and this should say meters. You could scribble out this one up here too. Should be meters, okay, per minute. So let's look at question number 3. I'm going to erase, okay, my graph. Question number 3 is done the same way as question number 2. Question number 3 says the following. What is the rate of change for line B from the 0 to the 4th minute? Again, they're saying from 0 minutes to 4 minutes. If they're doing 0 to 4 minutes, you're dividing by a total time of 4 minutes. But now we're using line B. Now line B at the 0 minutes starts at 0 meters. By the 4th minute, it goes up to here. And that, if you use the graph, is 400 meters, right? So we're doing 400 meters minus 0 meters, which again is a difference of 400 meters, and you're dividing by 4 minutes. I think you can easily divide this and tell me how many meters per minute it changed. Now, question 4 is done the same exact way that I did questions 2 and 3, except you're going to start at a different place for line B. I am not going to do this one for you. You're going to have to do this one yourself. But again, if you guys look at line B, it tells you to start at the 4th minute for line B. And again, the 4th minute, I'll just show you where to look for the information. But 4th minute, line B is at 400. By the 8th minute, it goes up to 600. So your change in values are the change in the heights. 600 minus 400 and divide by, again, it's 4 minutes between the 4th and 8th minute. So here was your 4 minutes, and you're going to do 600 minus 400. Okay, so that leads us to our last two questions. What happens to line B's rate of change after the 4th minute? We kind of already discussed the idea that with line B, it kind of steadily increased. Here was going up steadily, and then all of a sudden the line kind of starts flopping over. At the 4th minute, its rate of increase obviously starts to slow down. It starts to decrease how quickly it was going up. And then your final question says, do lines A and B show a direct or an inverse? Remember the difference between a direct and an inverse. A direct relationship has the line going up on the graph like that, whereas inverse has the line kind of decreasing. If you look at this, you can clearly see these are both a direct relationship. Okay, so that is procedure B. If you are not up to where you're supposed to be so far, you may pause this video and then come back when you are exactly where you should be. So let's start our last procedure, which is procedure C. So procedure C says a hot cup of coffee or hot cup of water was left standing on a lab table. Temperature was measured and recorded at 1 minute intervals. Plot the given data on graph B. Be sure to completely label each axis. So I'm going to put my time. Actually, the time in minutes has already been labeled for you down here, but what you got to do is label each line. So if I see I start at 0 minutes and my last time is going to be, actually, it gets cut off. It should say 15 minutes. I don't know why that got cut off. And again, the temperature at 15 minutes should say 23. Let's see if I can get this to write a little bit better here with the stylus. Okay, here it should say 23.0. So again, at the 15th minute, you got a temperature of 23.0. So your first job, guys, is to obviously label each line. Where X meets Y down on the X-axis here. Let's see if I can get down here. This is going to be 0, and the time for each line is going to increase on an interval of 1. So this should be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You get the idea. You don't need to go higher than 15. Okay, your data only goes up to 15. As a matter of fact, your data only went up to 14, but I gave you the 15th minute there, right? Then your temperature. Now, your starting temperature is 36. It kind of says it over here on the data, right? Starting temperature was 36, and your ending temperature is going to be 23. So I got to go from 23 up to 36. And one of the things that they don't always show you is your graph does not necessarily have to start at 0. As a matter of fact, I'm going to start this first line at 23. and then I'm going to go up by 1. So this is going to be 24, 25, 26, 27, 28, 29. This will be 30, 31, 32, 33, 34, 35. You should label every line. I'm not labeling every line because it just gets crowded looking and kind of sloppy, but you can label every line, right? Now, they want you to plot the data. At 0 minutes, right? Let's change the color of this pen here if I can. Come on up to the top here. And I can't change it right away. So let's just keep going. At 0 minutes, your temperature was at 36 degrees. So again, at 0 minutes, I'm going to come up to 36 degrees. I put my first dot. Again, I like to check my data off when it's done. At 1 minute, you're going to go to 32.5. So at 1 minute, here's 30, 31, 32 and a half. Would be about there. Connect the dots as you go. At 2 minutes, you're at 30.5. So if this is 30, 30.5 would be about halfway. Connect the data as you go. Check it off. Know that you did it. You're going to continue to plot your graph. You're going to see that it kind of slowly decreases until it levels out at the end. Okay, make sure you plot all points. Pause your video now until you can plot everything. Then return when you're done. Okay, so hopefully you plotted all your points, and then we answer the questions. Did the temperature increase or decrease? You can clearly see by both the data and the graph you had a decrease. Number 2, calculate the rate of change from the 0 to the 4th minute. So again, this is very simple. What you want to do is you want to think about the fact that this is a rate of change problem. Your time always goes down below, so this is a total of 4 minutes. And you have to look at your temperature at the 0 minute and the 4th minute, which would be here. So you started at 36 degrees. By the 4th minute, you were at 28 degrees, right? You're going to do 36 minus 28 to get a certain difference, and you're going to divide by 4 minutes. Again, it should be a certain amount of degrees divided by 4 minutes. All right, do your subtraction first, then your division. And in the end, of course, your answer is going to be a certain amount of degrees Celsius per minute. Make sure you stop the video here if you have to do your calculations. Okay, last 3 questions. Number 3, calculate the rate of change for the 4th to the 8th minute. From 4 minutes to 8 minutes is a total of 4 minutes. So again, down here, you're going to jot in 4 minutes, right? 4 minutes. You can go right back to the top. And at the 4th minute, you were at 28 degrees. By the 8th minute, you were at 24.5 degrees. So again, you're going to write those in. You're at 20, I think at the 4th minute, let me just refer to my data. By minute 4, you were at 28 degrees, so 28 degrees. And by the 8th minute, you were at 24.5 degrees. So again, subtract 28 minus 24.5. You're going to get a difference of 3.5. And you're going to divide that by 4. Make sure you do 3.5 in the calculator first. Divide by 4 minutes and you get your answer. It will be a decimal if you do it correct. And then guys, number 4, does this graph show a direct or inverse? If you don't know, refer to your vocabulary. Number 5, which is the independent variable, time or temperature? On most graphs, the independent variable is found on your x-axis. So if you go back up here and you simply see what is labeled on your x-axis, that's your independent variable. All right, guys, that is your lab number 3. Hopefully that went smooth for you. If it didn't, I recommend you go back and you watch and you kind of get it that way. All right, that is all. I will tune in with you guys for the next lab that we do. Hope you have a good day. All right.